Alright everyone, welcome back. Today we're talking about centripetal acceleration and centripetal force. Pretty much the main thing we'll be talking about and solving for throughout this chapter. Alright, so I guess one thing I want to talk about is this whole centripetal force thing. A lot of times people, if you've been on something that's spinning like this chairlift carnival thing, you're going to feel like something is kind of pushing you out. And you feel like, oh, there must be, and people call that a centrifugal force because something is pushing you out. However, that's not exactly the case. What's trying to push you out is this tangential velocity, okay? And what's actually keeping you in is the force. In this case, this string, this force of tension is keeping you in, making sure you're not flying out. So this centripetal force is the force that lets you spin in a circle. It's a force that points you inward, allowing you to go in a circle and not just fly out of there. Anyway, we're going to talk more about it, but it's just a common misconception people think about with centripetal force. Okay, so like I was saying, centripetal means center seeking, meaning when you're spinning in a circle, there's no force that's pushing you out. A lot of times when you're spinning in a circle, there's a force that's keeping you in, making you go in a circle. So centripetal force, in order for an object to be in uniform circular motion, a force needs to be acting on it. A force needs to be helping you to go in a circle, keeping you in the circle and not flying out of the circle. Centripetal acceleration. An object in uniform circular motion is always changing its velocity. When an object is in uniform circular motion, the acceleration is always pointed towards the object's center. Again, not away, towards the center. Tangential velocity. An object without a force acting on it always wants to move in a straight line. The direction that the object wants to move is the tangential velocity. And maybe we can see an example of this. Let's see. Like, for example, if we can imagine this be as a ball here. This ball here, as it's spinning in a circle, wants to fly outwards like this. However, this rod is what's allowing it to keep in a circle going this way. But every single time, it's wanting to fly outwards tangentially. But what's keeping it in a circle this time is the tension of the ball holding, of the rope or the wire holding on to this ball. Okay, so I know it's a little confusing. It'll make more sense as we do more of these problems, but I just want to talk about that a little bit. Here are the main formulas. So centripetal acceleration is equal to the velocity tangent squared divided by the radius. This is the main formula. And then you can see it being manipulated, algebraically manipulated over here. So if you want to copy that down or whatever, there it is. And centripetal force is mass times velocity tangent squared divided by radius. One thing I wanted to say is this force, centripetal force, is just mass times acceleration centripetal. Just as we've always seen it, sum of all forces equal to mass times acceleration. It's the same thing. Except this velocity tangent squared divided by radius is the same thing over here. This acceleration is equal to velocity tangent squared divided by radius. Okay, so I just want to say that the force is equal to ma is the same thing right here. Okay, here's the formula. As we can see, force centripetal is equal to mass times velocity tangent squared divided by r. And here are the algebraic manipulations to get the different values that you might want. Alright, so pretty short video. Next time we're going to be talking about centripetal force with horizontal motion. And hopefully the centripetal force will make more sense as we do those examples. Thanks for watching.